Okay, so of all the steps in this lab, this is the data table is the one that tends to trip students up the most. So I'm actually going to try to walk through it by numbering the columns. So column number, the first column, column 1, add a drawing here. Column 1 is just the mass of the bottle, and that's something you can just read off of your simulation. You'll notice you can choose whatever mass bottle you want, whatever volume bottle you want. The important thing is you use water and that it's on Earth. So you'll just wind up reading column 1 right off of your simulation. Same thing with column 2. The volume should be given to you. The force in air is column 3. And that is what the force sensor is reading, right? Because when I'm just going to make a little drawing down here. I'm going to pretend that's my bottle. It looks like a ball. We know that bottle has mass, and therefore it's got weight. And so there's this force downward we call weight. And yet when Isaac Newton is holding it, we know that it's not crashing down toward the ground. So that downward force must be balanced by an upward force. And that's the force that the force sensor is reading, which is your force in air. I'll put FA. So that winds up going up into column 3, whatever your force sensor is reading, but while the bottle is just suspended there before you submerge it, that is column 3. Column 4 is after you submerge it. After you submerge it, the bottle is immersed, and it may be completely submerged. It may only be partly submerged. The important thing is that your bottle, again, hasn't changed its mass, and therefore the Earth is still pulling on it with the same amount of weight. And what you should notice is that your force sensor is still going to be reading something, but most likely its reading is going to be smaller. So notice I'm going to draw it. So this is going to be force in fluid. So that's your force sensor reading after you have immersed your bottle. Again, it could be completely submerged. It could be only partially submerged. Notice that, if I can change my color here, notice that my force in fluid arrow is smaller than the weight arrow. That's really important. That's very important when it comes to column 5. Because column 5 is saying, okay, what's the difference? So notice that I must be getting some help, right? We need some other force upward to contribute, to add to the force that the force sensor is offering to balance out the weight of the bottle. That is your force difference. So in order to get column 5, we take column 3 and subtract off column 4. Okay, so that's going to go in there. The volume of the water displaced, which is column 6. Now that depends upon whether you're completely submerged or if you're only partially submerged. If you're completely submerged, column 6 should be equivalent to column 2. This is at the heart of Archimedes' principle. An object that is completely submerged displaces a volume of fluid equivalent to its own volume. Okay, so if it's completely submerged, column 6 is going to be equal to column 2. If it's not, then you really can't answer, you can't fill in column 6 because we don't know how much water is being displaced. At least we can't do it very easily. We can't just read it off, whatever the case may be. Now, column 7 is very important. The weight of the water displaced. So, we know by Archimedes' principle that there's going back to my other drawing here, that mystery force that seems to be helping out the force sensor in lifting up the submerged bottle. I'm going to put FB. That's the buoyant force. And the buoyant force is equal to the weight of the water displaced. So ideally, if you've done everything correctly, your column 7 should be equal to your column 5. Now there's another way of getting column 7. If your bottle is completely submerged, column 7 can be equal to your volume of water displaced, which was your column 6, times the weight density of water, which I gave as 0.0098 newtons per milliliter. So what you do is you take your reading in column 6 and multiply times 0.0098, and what you should wind up finding is that if you've done everything correctly, that your answer in 7 should be equal to your answer in column 5.